Hi, I'm Giginet. Today, I talk about the build system using Swift packages in Line. Hi, I'm Giginet. I'm a senior iOS engineer for developer experience team at Line Corp. Since I joined Line in July, I have improved the build system of the Line app. I also work as a committer for some famous open source DevOps tools like Cassage, Xcode, and Fastlane. I'm glad to talk at this conference. Today, first, I'll show you our current build system and its issues. Then, I'll introduce my new SwiftPM-based build tool. Using this tool, we can handle Swift packages as cacheable and reusable. Line is a communication application used by about 200 million users around the world. Line has a huge code base. Currently, we have about 2 million lines of Swift code only in iOS clients. This application has a lot of dependencies and pre-built tasks before building an application with Xcode. Currently, we are using Bazel for the pre-built tasks. Bazel is a build system developed by Google. We adapted Bazel 3 years ago. Thanks to this migration, build time has improved dramatically. These dependencies are not only regular libraries written in Swift, but also Objective-C. Others are written in C++ for like image processing. There are libraries distributed only in binaries. Next, Line has a large number of features. So some features, like payment, are developed in separate frameworks. Furthermore, there are code generation tasks to generate frameworks from API schemes. We call these built artifacts prebuilt frameworks. By building prebuilt frameworks, we can build application on Xcode. This process also takes a long time. So it's necessary to prepare pre-built framework and release them. However, the current build system has a large number of problems. The first is maintainability. Most tasks are developed in Starlark. This is a configuration describing language for Bazel. Our build system uses not only official rules, but in-house extensions. It's difficult to maintain. It's tough to run Bazel in addition. There are human members who have knowledge. There are one reason to spoil maintainability. Some dependencies are integrated by submodules. A lot of submodules spoil developer experience. Furthermore, surprisingly, there is no resolver for version constraints. When we aim to update dependencies, we need to resolve constraints by hand. As a result, it is difficult to update dependencies. So many dependencies are abandoned. Even still, Bazel had benefits because of its speed advantage. But since the introduction of the M1 Mac, it is almost no advantage. It also does not have many cache hits and does not take advantage of remote caching very well. Therefore, Bazel affects maintainability, running cost, and system complexity more heavily than the benefits of faster build times. To improve this situation, we have been replacing Bazel with a new build system since the beginning of this year. The requirements of the new system are following. First, simple, based on the standard build system, reusing build artifacts and caching well, easy to develop and testable, easy to update dependencies, not by hand. Currently, using Swift packages and Xcode integration is the best solution for iOS app dependency management. Unfortunately, it is difficult to store build cache using Swift package integration in Xcode. Build artifacts are stored in derived date, which is easily parsed. This solution may affect build speed when you have a huge number of dependencies, such as Line. On the other hand, adapting the standard Swift package ecosystem is a good choice. Since the release of Swift packages, most dependencies can be deployed using SwiftPM, and they will be maintained in the future. How can we conform to the standard method while keeping build speed? Therefore, I'm developing a new build tool, Scipio. Next, I'll show you how this improves build workflow. Scipio converts Swift packages into a portable binary that can be easily reused. I named this build tool Scipio. It comes from a historical episode in Cartago. I aim to replace Kaisage, which was a widely used build tool. This tool has a cache system. Thanks to this feature, developers can also save build time. As a design principle, Scipio aims to follow the Apple standard build system as much as possible. Scipio relies fetching packages and resolving version constraints on SwiftPM. After resolving dependencies, it converts each Swift packages into an XCFramework. Let's review XCFramework. XCFramework is a binary distribution format released by Apple in 2019. It allows for bundled distribution of frameworks for multiple CPU architectures and platforms. The entity is a directory that bundled multiple frameworks. For example, simulator binaries for ARM64 and x86 64 can be included in a single XCFramework. The XCFramework can be easily linked from application projects, making it very easy to handle. It also offers in distributability. Let's take a look at the practical workflow for using Scipio. First, prepare package manifest that describes that list of dependencies you want to integrate into your application. It's described in user package.swift. In the user integration with Xcode, the package manifest is written in GUI on Xcode project. But in this workflow, you have to prepare an empty Swift package that describes the dependencies. Execute Scipio for this package. Then it will generate XCFrameworks for all dependencies. Even if a dependency depends on another packages, it is handled recursively. How does it work? Scipio first uses the standard SwiftPM feature to retrieve the package and resolve dependencies. Then it generates an Xcode project from them. Finally, Scipio uses Xcode build to generate XCFrameworks for each package. Scipio not only generates package but also has a cache system. This system prevents a package that has been built again. To achieve this, metadata files are generated within frameworks are built. It's called a version file. This mechanism is inspired by cassage. The version file is in JSON format, which stores build context like compile version or build option using when the XCFrame was built. This allows Scipio can know existing XCFramework is same or not with it is going to build. Scipio supports 3 levels of caching. First, the project cache is the simplest. This strategy simply stores version files at the framework output destination. Then, if existing frameworks are valid, it skips building. This is convenient, but only the last build files can be reused. This cache is a strategy to save the built XCFramework and version file to separated disk space. It generated a SHA-256 hash from the version file. Built frameworks are stored by the hash under the system cache directory. This strategy allows to restore and reuse of frameworks that have been built in the same context in the past. The further development of this strategy is remote cache. It uses remote object storage like Amazon S3 instead of local file systems. This allows a workflow in which all developers can use the framework generated by CI. Since unveiling Swift packages in 2019, it can now support most use cases. Using them, we started to migrate existing dependencies into Swift packages. First, supporting packages written in C family languages. Currently, we can build most library written in C or C++ with SwiftPM. Since Swift 5.3, SwiftPM supports binary frameworks. This feature allows to treat distributed frameworks in binary as Swift packages. We can use artifact bundles since Swift 5.6. Swift 5.6. They help to distribute development tools. Artifact bundle is a mechanism to use prebuilt executables in Swift packages. A good example is code generators. Currently, we are using Bazel to build code generators. However, using artifact bundles prevents rebuilding them each time. Using these features, most part of the dependency of line will be migrated to Swift packages. Finally, I'll talk about future works. Scipio aims to consist only of standard tools. However, there is no way to generate Xcode projects from Swift packages. I worry that this will be fragile. Nevertheless, I believe that confirming existing dependencies to Swift packages is a good approach. It helps to migrate smoothly when an official Apple new cache system comes in the future. Currently, we are working on standardized dependencies. In the future, many in-house libraries will be replaced with one using Swift packages. Scipio is still under development. Please watch for future releases. That's all. Thank you for listening. Do you have any questions? Let's discuss on the speaker chat. Thank you.